Hey y'all, welcome back to another exciting round of chemistry notes. In this video, we're going to talk about the metric system and conversions. First, we're going to talk about the conversions. A conversion is a statement of equality which describes the relationship between two similar quantities expressed in different units. So an example might be 1 dozen is the same as 12 eggs, right? I can say 12 eggs, I can say a dozen eggs. I'm talking about the same amount of stuff. I'm just using different units to talk about it. A conversion factor is a fraction derived from a statement of equality used to convert from one unit to the other. So if my statement of equality was 12 eggs, we'll do it backwards this time, is equal to 1 dozen, I can turn that into fractions, into conversion factors by doing 1 dozen over 12 eggs. So this would be the conversion factor. This is the fraction that I get from my statement of equality over here. Conversion factors are always equal to 1 because anything divided by itself is 1. So 4 over 4 is the same as 1. 2.73 over 2.73, that's the same as 1. So 12 eggs over 1 dozen. Again, these are different units, but they're describing the exact same amount of stuff. So this is really still just 1 because it's something over itself. Since they're equal to 1, when you convert, when you multiply by these fractions, you are not changing the amount of what you have. All you're changing are the units that you're using to represent it. Every statement of equality, every statement like 12 eggs equals 1 dozen. Everything like this can potentially give you 2 conversion factors because you could say 12 eggs over 1 dozen, but you could just as easily say 1 dozen over 12 eggs. So we're going to be using these fractions, we're going to be multiplying with them. You need to know how to decide whether you want to use this one or this one. And in order to decide, you're going to choose the conversion factor that will cancel your undesired units, get rid of them, and it will leave you with your desired units. So let's look at a couple more examples of this, just figuring out this whole statement of equality conversion factor thing. So we've been talking about our 12 eggs and 1 dozen example. We can also say there are 525,600 minutes in 1 year. So that's our statement of equality. We're saying that 1 year is equal to 525,600 minutes. So this is our statement of equality. These two things are equal to each other. For our conversion factors, we could therefore say 1 year over 525,600 minutes as one option, or we could just as easily say 525,600 minutes over 1 year. These are both just as valid as each other. Depending on the problem we work, it'll help us to decide which one we want to use. A less elaborate number, something a little more familiar, we could also say there are 2 shoes in a pair. So if there are 2 shoes in a pair, our statement of equality written as a sentence, we could also write it as 2 shoes equals 1 pair. So So this is really showing our two equal quantities. So then if we wanted to write our different conversion factors, there are two options. We could either say 2 shoes over 1 pair, or we could just as easily say 1 pair over 2 shoes. All right, so hopefully this is making a little bit of sense. At this point, I'm gonna give you a minute to practice. Go ahead and pause the video, work this table at the bottom of page 20. When you're ready to check your answers, go ahead and unpause. All right, so hopefully this is what your table looks like down at the bottom of page 20. I understand that fluples and farples are not a thing, but in a second we're gonna start using our conversion factors, and a lot of people try to take a shortcut that's kind of gonna hurt you in the long run to use. So by throwing in some fake units, I sort of remove that shortcut from you, and I will point out what I mean when we get there. So if this is not what you got, take a second, look it over, see if you can see why this is the right answer and not what you put. And we're gonna move on, talk about how to use these. But first, one last thing we have to look at before we can move on to conversions. We need to review the metric system. Hopefully you've seen this a little bit, at least in middle school and maybe even elementary school. If not, it's not a big deal because the metric system is a really simple system. That's sort of its whole goal, is to simplify things for us. And it does this by using a single base unit. So instead of the imperial system, which we use here in the US, which measures distance with inches and feet and yards and miles, all of which are related to each other by different awkward numbers, the metric system measures distance in meters. That's it, that's the base unit. Every distance you could ever talk about is some kind of meter. Volume is in liters. Mass is in grams. And sometimes it doesn't make sense to use those units exactly. Sometimes you're talking about something really, really big, really long, and you need to talk about it in terms longer than meters, or maybe you're talking about something teeny, teeny, tiny in volume, and you need a unit that's smaller than liters. But the metric system has something for that too. Multiples or submultiples of 10 of your base units are expressed using a series of prefixes. They look like this. All right, so we've got all of our base units right here in the middle. It could be a meter, a liter, or a gram. Above that, these are for very large things. If you've got something very big, you're gonna use these prefixes up here. These are big prefixes. So a gigaliter is a really, really huge volume, or a kilogram is a pretty big mass. Down here, these are your little volumes, your little masses, your little distances. A nanometer is tiny. A microgram is tiny. These are very, very small. And the farther down you go, the smaller you get. The farther up you go, the bigger you get. These are prefixes. These are things we are going to use all year long. And as such, it is important that you memorize them. As far as what I need you to memorize, I need you to know that the prefix giga has the symbol big G, and then I need you to know one of these two columns. You do not have to memorize both of them. These are just sort of different people's brains work a little bit different way. I will tell you that during class and in my examples and in my keys, I will be using this column on the left-hand side because this one makes the most sense to me. I think it's the easiest to learn, the easiest to use. If you are looking at this column on the right-hand side and saying, I don't know, Ms. Childs, I think this one looks better, that's great. They are going to get you to the exact same place as long as you're using them correctly. Just be aware, I'm going to be using the left-hand side in my examples. So you need to know that giga has the symbol big G, and you need to know that 1 giga unit is equal to 10 to the 9th base units. You need to know that 10 to the 6th micro units, this little kind of looks like a weird U, it's actually the Greek letter mu for micro. You need to know that 10 to the 6th micro units are in 1 base unit. Those extremes are a little harder to think about, but how about, let's look at centi, right? Centi we're pretty familiar with. The prefix centi has the symbol C. So we could talk about centimeters would have the symbol cm. There are 10 to the second C unit, centi unit, so there are 10 to the second centimeters in every 1 base unit, so every 1 meter. Or we could say there is 1 kilogram for every 10 to the third grams. Pretty much anywhere you see unit or base unit, you can replace it with meter, liter, or gram, and it's going to give you a statement of equality, which we can then use as conversion factors. You need to know the prefix, the symbol it goes with, and the statement of equality. So you need to know that giga means 10 to the 9th, that there are 10 to the 6th micro units in 1 base unit. If you have questions about what I mean by that, come let me know. I will explain it again in person. But in the meantime, we're finally going to put these together. We are going to use these in a beautiful process known as dimensional analysis. Dimensional analysis is another all-year skill. So our chemistry friend is really excited about this because it's going to make him a much better chemist. It's going to make it easier for him to do chemistry math all year. What is dimensional analysis? Well, dimensional analysis is the process of using conversion factors, those fractions, to convert between units. And this is a process that might take you a little bit to really get comfortable with, but it's a pretty standard process. We have the same steps we're kind of going to go through every time, and if you start to repeat them to yourself in your head or even out loud as you do them, you'll start to sort of get the rhythm of how dimensional analysis works. So your steps, when you realize that you are faced with a dimensional analysis problem, which we'll see some examples that will help you know that you're being faced with a dimensional analysis problem. As soon as you know, you are going to start by writing down what you know. Easy enough, right? It'll have to give you some number in the problem, tell you something to start with, write it down. Once you've done that, you're going to multiply by a fraction. And this step really just means do times and then a fraction line. The next steps are going to tell us how to fill in the fraction. We're going to do this by filling in the units of our fraction before we worry about any numbers, just the units first. Specifically the bottom ones, because what goes up must come down. I'm going to explain this one when we work through a practice, but for right now, just remember this right here. What goes up must come down. And you might have to do these steps a couple of times. You might follow step number 4 and then have to go back and multiply by another fraction and then fill in the units, and then what goes up must come down and times another fraction. It'll just depend on the problem. You'll know that you're done adding in fractions, multiplying by a fraction, when the units in the top of the last fraction are the units of your answer, are the units of the thing you are looking for. When that happens, it's time to math. And as a hint, if you're struggling to convert from one prefix to another, like if you're being asked to go from milliliters to microliters and you don't know off the top of your head how many milliliters are in a microliter, you can always pass through that base unit first, because those are the conversions that I'm asking you to memorize from the previous page. All right, 5 steps. Start with what you know, multiply by a fraction, fill in your units, what goes up must come down, and when the units in top are correct, it's time to math. And honestly, 1, 2, and 4 are the big 3 steps. If you can get those 3, the rest will kind of fall into place. Let's see it in action. First example says, how many centimeters are in 2 meters? So do you remember earlier when I said that some people will find a shortcut that can just sort of hurt them in the long run? You probably can just look at this question and tell me, like, okay, well, miss, there are 200 centimeters in 2 meters. I'm done. Let's move on. The problem is that you won't always be able to do this. Later in the year, we're going to start using units that does not work for. You can't take this shortcut. So we are going to learn to do the steps now when there are problems that kind of make sense to us, that we can check our answers as we go. So it's great if you know this should be 200, but I need you to prove it. I need you to show your work. Dimensional analysis problems will sometimes be fairly simple. They will sometimes be fairly complicated. They are going to show up on so many of your tests, so many of your homeworks, so many of your lab reports. They're going to show up everywhere. And if it is something that you are writing, like say the free response to a test, you need to show your work. All right, no work, no credit. You have to show your work, and you have to show it the way we are about to go through it. So make sure you're following through with this process. Okay, now without any further ado, how many centimeters are in 2 meters? Well, we don't know the centimeters. That's what we're looking for. We know the 2 meters. This was told to us. So it's what we know. We're going to write it down. Start by writing down what you know. I know 2 meters. Step 1, check. Step 2 was to multiply by a fraction. All right, easy enough. Step 3 is to fill in the units first. So we're going to ignore the numbers out front for a second and just focus on the units. But still, we don't know what units to put in. This is where step 4 comes in. What goes up must come down. The units that you start with are essentially in the top of a fraction. We could say this is over 1, and we're not changing anything. So this is like being in the top of a fraction. Later, when we have multiple fractions, there will be actual tops of actual fractions. But for now, these units out front are in the top, and what goes up, as in the unit of meters, must come down. So we're going to put our units of meters right there in the bottom of our fraction. From meters, we can get to like any other unit of length. We can go to kilometers, we could go to micrometers, we could go to hectometers. There are a lot of different ometers, but we're looking for centimeters. So since we're trying to find centimeters, we're going to put centimeters in the top. And now we can fill in our numbers. And this is where you're going to need to know your metric system, because I'm going to say, which one of these is bigger, a centimeter or a meter? Well, a centimeter is about that long, and a meter is about 100 times longer than that. So meters, pretty big. We're going to say there's 1 meter here. Within that 1 meter, you need to know that there are 100 centimeters. This is a conversion you need to know. And now we have filled in our conversion factor, 100 centimeters over 1 meter. So the statement of equality we used was 100 centimeters is equal to 1 meter. That's our statement of equality. This is the conversion factor we got from it. In a different problem, if we were going from centimeters and trying to find meters, we would probably use 1 meter over 100 centimeters. Because again, they are both true. It's just that in this case, in this problem, this is not helpful to us. We want to use this one. So moving right along, let's look at step 5. When the units in the top of your last fraction are the units of your answer, you're ready to math. Well, the units in the top of our last fraction are centimeters. We are looking for centimeters in our answer, so that means it's time to math. This math is pretty straightforward, right? We will do 2 times 100 divided by 1. So eventually, I'm not going to show you this work. Hopefully, eventually you do not need this work, but since we're still sort of easing into the math here, this is going to become 2 times 100 over 1, which becomes 200 over 1, which is just 200 centimeters. All right, that's what our calculator told us. That's what we know the number should be. But now we need to stop and check and look for sig figs and units to make sure our answer is completely correct. We started this problem with one significant figure. We had a conversion factor that had one significant figure. However, as you may recall from our sig fig notes, conversion factors don't count. So we don't actually have to look at this at all when determining our sig figs. The only thing that matters is the number we started with. Our given had one sig fig, so our answer should have one sig fig, which it does. So we've got correct significant figures. We were looking for centimeters. We wrote down our units of centimeters. This is our final answer, which again, we said several minutes ago, that's exactly what we said it was going to be. But now we have proven it, and we will actually get credit for this work. All right, number 2 here. A student has a 4.35 times 10 to the 16th kilobytes, KB, of data stored on her computer. How many megabytes is this? So we are looking for this number in megabytes. We are told that we have this number, so this is what we know. We are going to follow our exact same steps. I'm just going to tell you, we'll need a couple more this time. So we will start with what we know, which is 4.35 times 10 to the 16th kilobytes. We will multiply by a fraction. We will fill the units into that fraction by saying that what goes up must come down. So those units of kilobytes that we started with will come down into the bottom of the fraction. If you can go straight from kilobytes to megabytes, awesome, do it. But I'm not going to assume that you know how to do it. We are going to go to our base unit first. So we will go to just bytes, and then we will fill in our numbers. Ask yourself which one's bigger, a byte or a kilobyte? Well, a kilobyte is bigger, so we'll say we have one of them. And then how many bytes are in a kilobyte? Well, this prefix kilo means 10 to the third, or 1,000. So there are 1,000 bytes in 1 kilobyte. Now the units in the top of our last fraction are bytes. That's not the answer we're looking for. We need an answer in megabytes. So the fact that the units in the top of our last fraction are not correct means we are not done. So we are going to take these units and convert from bytes to megabytes. So since we need to convert these bytes, we will do times another fraction. Once again, what goes up, and this time these bytes are very clearly up, must come down. So we will bring these units, and again, it is just the unit, not the number. We will bring the units down. So now we have bytes in the bottom, and because bytes are our base unit, we can again go pretty much anywhere we want to go. In this case, we want to go to megabytes. So we will put megabytes up in the top. Then you need to ask yourself, which one is bigger, a byte or a megabyte? And because we are memorizing our metric system, we know that a megabyte is bigger. So we'll say there is 1 megabyte. This prefix mega means 10 to the 6th. That is 1 million. At this point, I'm going to recommend that you don't write out the full number and just call it 1 times 10 to the 6th bytes in 1 megabyte. And now the units in the top of our last fraction are the same as the units we are looking for in our answer, which means it is time to math. At this point, we are going to put this into our calculator. And to type this in, the keys you are going to hit are 4.35 second, comma, 16 times 1,000 divided by 1 second, comma, 6. Right, 4.35 times 10 to the 6th times 1,000 divided by 1 times 10 to the 6th. And if you type it in this way with the second comma notation, you don't need to worry about parentheses because your calculator will know exactly what you're trying to tell it. And when you hit enter, your calculator is going to say 4.35 times 10 to the 13th megabytes. And we should double check our significant figures. We started with 3 out front here in our given, and we've got 3 here in our answer. So we're good on significant figures. We are told we're looking for megabytes. Our answer is in megabytes, so we are done. Put a box around that. All right, so again, you could have just gotten through this by taking some kind of shortcut. Our next problem, you're not going to be able to do that because our next problem is going to convert between tillers and silly buckets and yellow really boppers and stead butts and silly buckets. So we're going to have to follow these steps now. There's just no getting around it. So we are going to start the exact same way we've been starting by reading the question. We are given some conversion factors below to answer a question, which is how many yellow really boppers are equal to 18 tillers. So this is what we know. We know we are starting with 18 tillers, and we are looking for yellow really boppers. So let's write down what we know. 18 tillers. You might want to write a little small for this one. It's going to go on a while. We will do times a fraction. What goes up must come down. So that means that our fraction will have tillers in the bottom, and we will have something in the top. To figure out what goes in the top, we're going to look at our conversion factors up here. I see tillers in exactly one place, which means from here, the only unit we can get to are silly buckets. So that's the unit we're going to put in the top of our fraction, our silly buckets. In this case, we don't have to have anything memorized. We are told that our statement of equality is 24 tillers are equal to 7 silly buckets. That means to fill in our numbers, we will say 7 silly buckets over 24 tillers. We're just going to use the numbers they gave us. Now we have silly buckets in the top, but we are looking for yellow really boppers. So we are going to do times another fraction. What goes up must come down. So we will put silly buckets in the bottom of this next fraction and some unit in the top. Let's go back to our conversion factors here. I see silly buckets here where we just saw it, and I see silly buckets down here. Well, we don't want to go back to tillers because that's just going to take us back to where we started, which is not a good use of time. So we probably want to use this conversion down here to stead buttes, to stead buttes. That's what we're going to call it. Yeah. So we're going to put our stead buttes up here in the top. And once again, to fill in our numbers, we are just going to use what we were given. 8 stead buttes in 3 silly buckets. Now we have stead buttes in the top. That is not what we are looking for. We are looking for yellow really boppers. So we're going to do times another fraction. What goes up must come down. So we will put our stead buttes in the bottom. And to figure out what goes on top, we'll go look at our conversion factors again. So we've got stead buttes down here where we just found them. So probably we don't want to use that again. Or we have stead buttes right here across from yellow really boppers, which is what we were trying to find. So we're going to put our yellow really boppers up in the top. Our statement of equality says there are 21 yellow really boppers for every 2 stead buttes. So now we have the units that we are looking for in the top of our last fraction. And since the units we are looking for are in the top of our last fraction, it is time to math. This is going to be a big one. We're going to type into our calculator, everything in the top gets multiplied and everything in the bottom gets divided. So if we just wanted to go straight across, it would be 18 times 7 divided by 24 times 8 divided by 3 times 21 divided by 2. If you want to type that in a different way, that's completely up to you. But everything that is under a fraction should be divided. Everything that's over a fraction should be multiplied. And when you type that into your calculator, it should tell you that there are 147 yellow really boppers. And that was a fun problem. So after that, we find that there are 147 yellow really boppers for every 18 tillers. A quick note about this, I sort of glossed over it earlier. We said that dimensional analysis exists to help us cancel out our unwanted units. Well, we haven't really been marking that as we go, but you can see in these problems that units we don't want, units we're trying to get rid of, have been showing up in the top of one fraction and in the bottom of the next. So here we have silly buckets on top and we have silly buckets on the bottom. So we essentially have silly buckets over silly buckets. And as we said earlier, anything over itself is just 1. It just cancels out and goes away. So anytime you have a unit in the top and in the bottom of a fraction, so here's silly buckets in top, silly buckets in bottom, they cancel out and go away. So tillers is out front, which remember we said is like being in the top of a fraction. Here's tillers in the bottom. It cancels out and goes away. Steadbutes is in the top here, and then in the next fraction, steadbutes is in the bottom. It cancels out and goes away. The only units that didn't cancel out are the units of our answer, the units we wanted, these yellow really boppers, because they only showed up one time. So all the units you want to get rid of will be there twice. The units you want to keep, those being the units of your answer, show up once. All right, this is 100% one of those topics that does you no good to just watch someone else do it. You have to practice it. So there's a lot of practice in your book to help you. At this point, go ahead and move on into your book. There are 11 practice problems for you in the book. I will post more on my website if you just want more practice. Go through these, show all of your work, all of your fractions, follow your rules. If you don't want to circle and draw your arrows for what goes up must come down, you don't have to do that. But you do need to show all of your fractions. Build these habits, get comfortable with it, so that when you have to do it quickly on a test, it is just second nature to you. All right, it is time to practice. Go ahead and work those problems. You might take a couple of breaks in the middle this time if you're feeling a little overwhelmed or a little drained, but pause the video, and when you are ready, unpause it to see the answers. That's it. Hopefully this is what you got, and they do need to look exactly like this, the correct sig figs and the correct units. Anything besides that would get you partial credit on a test, but not full credit. So if you are not sure why these are the answers, be sure to head over to my website where there's a full key posted that walks you through the steps, shows you every fraction, all of the what goes up must come down goodness of dimensional analysis. And if you are feeling uncomfortable with this one, please, please, please come into me or some other teacher as soon as possible, because, and I know I've said this in the last few videos, this is a skill we are going to use all year, every quiz, every test, every unit. So you need to be comfortable with it. All right, if you need to, go back and study some more or head on over to your quest and work on that. Either way, good luck and happy studying.